Which triangle appears to have an obtuse angle? Okay, well, let's start with answer choice A. It's the first one. If I check that angle there on the bottom, my sticky note fits perfectly. It's not too big, it's not too small, it fits just right. That means this is a right angle. When we talked about lines and angles, we learned a little bit about triangles, and we said that every single triangle, no matter what the size, no matter what kind of triangle it is, will always have at least two acute angles. Which means that if this angle is right, this angle is acute, and this angle is acute. Now, if you didn't remember that, that's fine, because if I check it, I'll see the same thing. Both of those other angles are too small for my sticky note. The sticky note does not fit in those angles. Part of them gets covered up. So I have a right, an acute, no obtuse angles. Okay. Triangle B. Same thing. I've seen this before on this test. My sticky note fits. There's plenty of room, but it's too big. Part of my angle is sticking out to the side, and if it's sticking out, that means I have an obtuse angle. And again, every single triangle, no matter what the size or what kind of triangle it is, has to have two acute angles. So answer choice B has an obtuse angle. Answer choice C, if I take a look at it, no matter what angle I check, every single angle is too small. There's not enough room. These are all acute angles. And answer choice D is very similar to answer choice C. No matter which angle I check, I can see that my sticky note doesn't really fit into any of the angles on my triangle. They are all acute angles. The only triangle that had an obtuse angle was B. That's the only triangle they showed me that does have an obtuse angle. Number 6, Pat traced and labeled the rhombus shown below, JKLM. Here's his rhombus. On Pat's rhombus, line segment JK is parallel to line segment blank. So they're looking for something parallel. This is the line they're looking at. Line segment JK. F says line segment KL. KL is right here. Remember, parallel lines, no matter how far you stretch them out, never ever touch. And I can see that this line is already touching. Line JM. Same thing as KL. If I look at line JM, I can see that line JM is already touching. Line ML. Here's line ML. It's not touching yet, and if I stretch out my line, I can see that they won't be touching, no matter how far I stretch them out. J says not here, but I already found a line that's parallel. Line ML. Number 7, Francis has a piece of tissue paper shaped like a square. Francis wants to fold it in as many different ways as possible to show how many lines of symmetry there are in a square. How many lines of symmetry does a square have? Okay, again, they're asking me about a shape, a square. How many lines of symmetry does a square have? When they ask me about a shape and they don't show me the shape, I draw it myself. So there's my square. And I need to figure out how many lines of symmetry this square has. I could fold a square vertically, just like that, and have two congruent sides. I could fold a square horizontally, like that, and have two congruent sides. I could also fold a square diagonally. Either way, so it could be diagonally this way, it could be diagonally this way, and either way, I would have two congruent sides. Now here's the tricky part. I have one line, goes from here to here. Two lines, here to here. Three lines, here to here. Four lines, from here to here. This is the same as the first line. So I don't keep counting. This is not 5, 6, 7, or 8. There is only 1, 2, 3, 4 lines of symmetry in a square, which means that I need to pick answer choice C. Question 8. These quadrilaterals belong in the same group. Okay, so they give me the shapes this time and they draw them for me, which is very nice. It means I don't have to draw them myself. It says, which statement best describes the quadrilaterals in this group? Each quadrilateral has 4 right angles. Some of them do. I see a square and I see a rectangle. Like we said earlier, squares and rectangles have to have all right angles. But these ones in the middle, parallelogram and the rhombus, they don't have the same rules. And if I check them with my sticky note, I can already see my parallelogram has an obtuse angle because that angle is too big for my sticky note. I can see the same thing in the rhombus. If I try to put the sticky note into that angle, it's also too big. So I know that they don't have 4 right angles. Not all of them anyway. The square and the rectangle do, but not the parallelogram and the rhombus. G. Each quadrilateral has 4 equal sides. The square absolutely does. Has to. It's a square. Squares have to have 4 equal sides. So does a rhombus. A rhombus has to have 4 equal sides. But a parallelogram does not. A rectangle does not. And I can see in the rectangle that it's got long sides and short sides. So they can't have 4 equal sides. because only some of them do. H. Each quadrilateral has two obtuse angles. Well, I know this parallelogram does. Got two obtuse angles. I know that this rhombus does. But the square and the rectangle have to have four right angles. They have to. And if they have four right angles, there's not enough space to have anything else. So they can't have two obtuse angles. J, each quadrilateral is a parallelogram. Now remember, we took some time, especially with quadrilaterals, and we saw how a lot of quadrilaterals had things in common, things that were the same between the both of them. Parallelograms are pretty simple. Parallelograms need to have four sides, they need to have no openings, and they need to have two pairs of parallel sides. That's it. Every single one of these shapes has four sides because they've told us that they are quadrilaterals multiple times, and I could count them. Now all I have to do is check, do they all have two pairs of parallel sides? Well, the square certainly does, the left and the right, the top and the bottom. My parallelogram does, the left and the right, the top and the bottom. My rhombus does, this side and this side, this side and this side. And the rectangle does too. The left and the right, top and the bottom. All of those have two pairs of parallel sides. That means that each of those shapes is also a parallelogram.